comparing and ordering. Okay. And this could be a little confusing for some people right off the bat. But take a look at this here. If I have the number 1, and I am comparing that to, let's say, 0.7, well, yeah, 0.784. And I asked you which of those two numbers is bigger, which one would you tell me is bigger? Not which one has more digits, but which one means more? Is it better to have one of something, or if it's a good thing, 0.784 of it? Maddie? 1. And that's the first thing we have to think about, okay? If you have a whole number, and this one's just a decimal, I could put a bazillion digits after this number. And the number 1 is always going to be bigger than that decimal number, no matter how many digits it is. Because when you think about decimals, every place you get past the decimal, that stands for a smaller and smaller and smaller amount. Okay? We know this one stands for 1/10. So this means I have 7/10. If I was talking about, if I had a rectangle, here's my one rectangle. If I was looking for this 7/10, that means I cut this into 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 7 of them. Okay, this is how much 7/10 is right here. So obviously one whole thing is bigger than 7/10. But what is 8? This 8 is how many hundredths? This is how many hundredths. So that means I have, in addition to these 7/10, in addition to the 7/10, I have another 8 hundredths. But do you know what 8 hundredths is? 1/100th is a tenth of each of these little squares. So let's look at the experiment here, and let's blow that up a little bit so you can see it. So that means plus that 7/10, I have to take one of these and split it into 10 pieces. 1, 2, 3, 4, 5, 6. Sorry, that was close on that. Let's try to get it close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have how many of those? 8. 8 of those pieces I just made there. So 1, 2, 3, 4, 5, 6, 7, 8. So there I have my 7/10 plus my 8 hundredths. Okay, it's a little closer to 1, but it certainly isn't 1 equal to that whole box when I started with. Now this next one, which is a 4. That 4 is in what place? Everybody know what comes in the next place? Thousandths. Which means I have to, in addition to what I have here, I take this next box, because this was hundreds, and I have to cut it into 10 little pieces here, which means I may have to explode this a little bit higher. Let's go a little bigger. Okay. I need to take this and cut it into 10 pieces. 1, 2, 3, it won't even let me do it. My pen's so far off. I have to cut it into 10 pieces, and how many did I have? 4 of them? Yeah. So that means I have about this much of this next thing. Okay? The next place after that is the 10,000ths place. What was my number after that? 4 what? 5. So that means I have to take, I can't even do it. I have to take one of these thousandths that I had up there and split. I don't know if I can make this any bigger or not. Oh yes, I can. And I have to split the next one into 10 pieces, which oh wait, I can do it. Look at it. Let me do it. And how many did I say I had? 5 of those? 4 of them? That was my next thing? What was in the 10,000ths place? 10s, hundreds, thousands. Wait, no. 10s, hundreds, thousands. I had 3 of those. So that means I color in 3 of these little guys. And then what was my next digit? 2. I don't know if I can go any higher. Okay, that means I have to take one of these itsy bitsy things and cut it into 10 equal pieces, and I have 2 of them. Okay, now I really exploded this, and I'm going to shrink it back to normal size, and you'll see how much a 1,000th or even a 10,000th is when I put it back to normal.
Oh,
Okay.
it's not
Yeah, you can't, and that's what, the farther away from the decimal you get, the smaller and smaller and smaller and smaller that amount is really worth. Okay? And think about it in terms of money. You know, the first place after the decimal is how many dimes you have, and 7 dimes isn't too bad. I mean, you'd probably take 70 cents if somebody would give it to you. You know, the next place is hundreds. Well, that's 8 pennies. Most people won't bend over for a penny anymore. But if we were to have that coin over here, which would be the mill's place, you'd have to have 10 of those to make 1 penny. Who's gonna, I mean, you'd have to have a whole handful, and you couldn't even buy a piece of gum or a stick of gum or what the cheapest thing in the world is. So, when you compare decimals, just know that 1 is going to be bigger than any decimal you could ever write, as long as there's no whole number in front of it. Now, what about normal? So we do this thing here. Put that there. What about when we have just a decimal like this, 0.86, and I'm comparing that to 0.806? If you're saying it out, it's 8600ths or 806 thousandths. That's the way you'd say it normally. Which one of those is bigger? Lance? 806 thousandths actually is not. Well, obviously you know the other. Don't raise your hand because you know the other answer is right. And here's how you know. Here's how you know. There's 2 ways you can think about this. You can compare the decimals 1 for 1. In other words, look at the decimal points. Look at the number right after the decimal. The first digit after the decimal is an 8. So right now they're both equal. The second digit here is a 6, but the second digit here is a 0. You can stop right there because 6 hundredths is bigger than no hundredths. This is bigger. That's one way to think about it. Another way to think about it would be you can always add zeros at the end of decimals. So if this has 3 decimals, I can make this have 3 decimal places and write it like this. This would be 860 compared to 806. Now what's bigger, 860 or 806? 860 is bigger. Okay, so it's not about how many digits a decimal has, it's about what digits are in what place. For example, if I had, let's say I have 0.0006, and I'm comparing that to 0.01, which one would really be bigger? Isabel?
0.01.
Right, because if this has 4 decimals and I add enough digits in there, you look at this, this is actually 100 and this is a 6. So this one would be bigger. Or if you did it 1 for 1, look, you go decimal point 0, they're the same. 1's bigger than 0. You don't have to know what comes after it. Remember, those after you get past them, they start getting smaller and smaller and smaller and smaller and smaller. Oh, here's one that most people get all messed up on. What's bigger? 0.70 or 0.7? 0.70 or 0.7, Brooklyn?
0.7.
0.7? No. Grace?
0.70.
No, I'm afraid not.
What? Oh, I knew it.
Laney? Yeah, they are equal. Like I said, you are always able to put, if this has 2 decimal places, digits after the decimal, I can always add zeros, and it's really 0.7 equal to 0.7. Okay, this is 7/10 with no hundredths, this is 7/10 with no hundredths over there as well. Okay, well, let's see, what about this one? 0.800 compared to 0.08. Which one is bigger? Jaden,
One on the left,
why?
but, it has an 8 and then its first number is an 8 and then the one on the right is first number is 2.
Right, you don't have to look anywhere past their first numbers. The first number here after the decimal is an 8, the first number there is a 0, you can stop right there. It doesn't matter what comes after it. I could have a bazillion numbers after this.
Let's do it again.
This one will always be bigger than that one. For the same reason as when we did the one thing. Okay. Now, they're also gonna ask you to do this. What if you have this? Write this down. 1.02, 1.2, and 1.12. And they ask you to order it from least to greatest. Write these down from least to greatest. So give me the smallest one first, and then the next smallest one, and then the biggest one. Order it from least to greatest, and tell me why. Of those three up there, which one is the smallest? Which one is the least? Stands for the least. Jenna, what do you think? Smallest one is?
$1.02.
1.02. Why? Yeah. If you look at the first of all, you look at the whole numbers. They're all 1, so they're equal there. First digit after the decimal 0. This is a 2, and that's a 1. So this has to be, no matter what, 0.102 is most definitely the smallest one there. The next one, Luke.
1.12.
Exactly, because this has a 2 after, then has a 1. 1.12 it is, and then 1.2. If again it helps you, you could put a 0 there. This is a 2 after the decimal. This is a 12 after the decimal, and that's a 20 after the decimal, and that would be the order in which they came. So I think you got it. The excitement just never ends.
There's more. There's more.